Hi, and welcome. So I'm going to be going through the Monte Carlo uncertainty analysis module contained within inside IP. So this allows you to determine the uncertainty for an entire workflow, not just for individual modules. So, for example, we can have analyze the uncertainty for our clay volume, porosity, water saturation, and cutoff and summation all together at the one time. Now this means that you can then get an idea of what the impact of some earlier calculations are on your final results. Within IP as well, you can also analyze many of the other modules, including a lot of the advanced modules, inside the Monte Carlo analysis workflow as well. So for example, if you have predicted out fascies and used these predicted fascies to determine A, M, and N values in your porosity water saturation calculations, you can include that prediction from your SOM or your cluster analysis techniques at the start of the Monte Carlo workflow, so that you will then have varying fascies and varying AM and N values used through the Monte Carlo simulation, and then the end results will allow you to see the impact that the fascies actually have on your final results. For today though, I'm just going to keep it a nice straightforward deterministic workflow. For all the modules that you choose, you will get a parameters tab. Now this will show you all the parameters that are available inside that given module. You can turn these on or off as you see fit, so you don't have to analyze all the parameters. You can just pick and choose if you want to do a more focused analysis. You also have the ability to run the analysis on your input curves as well as the parameters that you've chosen inside your modules. For all of these, you can choose different shift types. So we have linear, percentile, reciprocal shifts, and also the different shift distributions. So that can be Gaussian, triangular, or square. And you can apply the range that you want to use for that uncertainty analysis individually on parameter by parameter or on the inputs on there. We also have the ability to set up dependencies within these parameters. So for example, if you wanted to link your M and N exponents together, a correlation value of 0 means that there's no correlation. If you only put in a value of 1, then that is a positive correlation. -1 is an inverse correlation between these things. But to add in error for these things, you can put in values in between these. So they will move in the same direction as each other, but there is still room for that error. So you can define that error range inside there as you see fit. We can also define the output curves that we are analyzing. So in here we have effective porosity, our water saturation, and our volume of clay and wet clay in here as well. You can choose the number of simulations that you want to run, so you can define specifically how many iterations, or you can have it to stop the calculation or at a given point inside the model. So I'm just going to leave these there. You can then also choose what statistics you output to particular curves. So you have that option in there, and you can define specifically what percentiles you want to use in the reporting on there as well. Before we run the full calculation, I'm just going to have a look at the tornado plot in here. So the tornado plot allows us to choose one of our result values and then see what the impact of all the individual parameters and input curves are on that result there. So you can instantly get an idea of which parameters are having the biggest impact on your interpretation results. This can be done for the whole well, or you can do it on a zonal by zonal basis. So you can analyze these things as required. Now if I start the simulation, you will see that it runs quite quickly. as going through these things. And we can also start to have a look at this data in here as well. So we can have a look at histogram distributions, we can have a look at the cross plots of these things as well. And we can also have a look at the log data in here too. Now at any point I can pause the simulation as it's running through, and I can then continue running that. So that allows you to pause that, do something else if you need to quickly, and then come back and then continue the process. Now if you are happy with the results before it automatically stops, you can come in here, choose stop, and that will then finish those there. You can then have a look at your final result listings as well. And if we look at the log data inside here, if we just zoom in on these curves, you will see you have the original curve in here. We then have the P10, P90 and P50 cases also being displayed in here, and the area between the high and low cases shaded yellow, so it's really obvious where you have the largest amount of uncertainty, so you can easily pick that out from your results. So that is the Monte Carlo uncertainty analysis within IP. As we've seen, it allows you to easily identify the best and worst case scenarios for your given interpretations. You can also see how a specified range of inputs affects your end results. You can determine which parameters are then having the biggest impact on your results, and ultimately it allows you to save time by not having to rerun multiple scenarios manually. So thank you for your time. I hope you found this useful, and goodbye.